Hello everyone. In this video we are going to be developing um, this exercise related with patterns in a context of coordinates and lines. We also require to use the midpoint formula and also the distance between 2 points formula. So the problem is like follows. Um, a diagonal line starts at point A, 0, 4, which is this one, and reaches point B in 1, 0, which is this point. Also, uh, well, that first line is the red one. Also, a second diagonal line starts at point C, which is this one, and reaches point D in 2, 0. We also have M, this point, which is the midpoint between A and B, and N, which is the midpoint between C and D. B and D are going to be moving. Remember, this is B and this is D. They are going to be moving. So here you have the pictures of the first three stages, but here in Desmos we can actually see how it changes. So this is the stage 1. Now this is stage 2. This is a stage 3, and we can actually move further. Stage 4, stage 5. It's not quite visible completely. Stage 6, stage 7. So far so good. So again, stage 1, stage 2, stage 3. Here are the fixed static images, and here's the table. So we are going to be completing this table, this information. Okay, so let's go back to stage 1. We can do it by many ways, um, but let's do it just by looking at the points in each stage. So here you see B is changing like this. So remember this point. V, which is this one, and now we have the midpoints M and N. So what is the midpoint in the fourth stage? So let's move to the fourth stage, and the midpoint M has coordinates of 2, 2. Okay, let's write them. 2, 2. What about the midpoint in stage 5? These coordinates are 2, 5, sorry, 2.5, 2. Okay, but you don't need to be able to move this slider along and see each individual stage, because you can recognize that here is a linear pattern. The only difference with what you have done usually before is that the pattern is inside a coordinate, because you can recognize that the 2 is fixed, so it's always going to be 2 in the y part of the coordinate, but the x part is going to be changing, starting in 0, 5, then changing to 1, so we added 0, 5, and then if we add other 0, 5, we are going to get to 1.5, and then to 2 if we add other 0, 5, and then to 2.5 if we add again 0, 5. So that is how this pattern is changing. It's just inside a coordinate. Here, something similar happens. You can recognize that the the y part of the coordinate is fixed, and the x is changing by 1. It's always adding 1. So the next part is going to be 4,3, and the next one is going to be 5,3. And we can actually check that in the Desmos graph. let's see here is stages. 4 of m, sorry, 4 of n. Where is it? Where is it? Here. Stage 4, n. It's 4 comma 3, as we see, and stage 5 is going to be 5 comma 3, like always. Also, that's not the only way to do it, because remember, guys, that here m and n are midpoints, and we know how to find midpoints by using a formula. Remember the formula, give me a second, I erase here. The formula for the midpoint is like this: x1 plus x2 over 2, that's the x part of the coordinate, and y1 plus y2 over 2, that's the y part of the coordinate. And remember that m is the midpoint between a and b. And remember, a was fixed. Let's check again the graph. A is always this point, which is 0, 4. A is always 0, 4. And B, for the stage, let's say 4, B is 4, 0. So let's do the M for stage 4 once, so you can recognize how to do it, and you know that we could have done the same for all of these. So midpoint. So this is going to be x1, y1, x2, y2. Okay, and let's just replace in the formula. 0 plus 4 over 2, comma, 4 plus 0 over 2. So that is 4 halves and 4 halves. But 4 halves is 2, and 4 halves again is 2. So look, we got exactly the same. So you could have done exactly the same for n with b and d, and also for stage 5 in both cases. But now, here when you see the distance from m to n, this is not something that you have usually seen, because this doesn't follow a linear pattern. You see there's a square root, you see there's a denominator 4, and you see that the numerators are increasing, but the difference is not the same, because you see from 5 to 8 there are 3, but from 8 to 13 there are 5, so the difference is not constant, which is the definition of a linear pattern. That means this doesn't follow a linear pattern. But remember, this is a distance, the distance from m to n. And remember also that we have a formula that can help us find the distance. And it's this one. So x2 minus x1 squared plus y2 minus y1 squared also. And we can actually find this expression by making that formula with these 2 points. So for stage 4, m is 2, 2, and n is 4, 3. So we are going to label them x1, y1, x2, y2, and we just apply the formula, a distance between m and n. So it's going to be a square root, and let's do x2, 4 minus 2, that squared, plus y2, which is 3, minus y1, which is 2. So we square it. And then we simplify the expression, which is 4 minus 2, it's 2 squared, plus 3 minus 2, 1 squared. And we can simplify this even further, because 2 squared is 2 times 2, which is 4. 1 squared is 1. So this is the square root of 5. Actually, let me write that in a prettier way. Square root of 5. So we could have just written this inside. Square root of 5. However, this expression doesn't look like the others, because you see all of them have denominator of 4, so that should mean something. That should be related to the pattern. Even though this is the correct result, and we can even like use a calculator to give me a second, let me open the calculator. Wait, oh, something's going on with my keyboard. Don't worry, my numerical keyboard ran out of battery, so just let's calculator, or no, let's use Desmos. Here we can also make calculations. Let me show you. Squared, if I'm not mistaken, square root of 5 is approximately 2.23606, but we don't want that amount of decimal annoying places. Let's leave it like this. This is prettier. However, we want to rewrite this as an expression with a square root, and inside a fraction with denominator 5. So how can we transform it to something like that? Well, it's easy, because remember, every single number can be written as a denominator 1. Yep. So let me widen the square root. Yeah. All the fraction is inside. So it's 5 over 1. But if we want to match the denominator, so we should multiply by 4, and we should also do it up. So 1 times 4 is 4, and 5 times 4 is 20. So the expression that we would like to have here is a square root of 20 over 4, which is 5. Just written in another way. And let's find the other version. Let's find stage 5. Okay, let's do it. Let me change of color. Let me resize this. So again, stage 5. So in this case, m is 2.5, 2, and n is 5,3. Again, let's find the distance by using the formula, which will be something like this. So again, let's label them. Let me do it with another color. x1, y1, x2, y2. Again, x2 minus x1, so it's 5 minus 2.5 squared plus y2, 3, minus y1, 2 squared. 5 minus 2.5 is 2.5. And 3 minus 2 is 1. Let's continue. So 2.5 squared, let's actually do it here in Desmos. 2.5 times 2.5. That's 2.5 squared, which is 6.25. 6.25 plus 1 times 1, which is 1. And if we keep doing it, oh, sorry, I forgot the equal signs. 6.25 plus 1 is 7.25. So it's a square root of 7.25. We could go even further and write that in decimals to get the decimal version of that, but it's going to be an irrational number, and we don't necessarily want that right now. But again, oh, sorry, it's denominator 4. Excuse me. You should have been like screaming at me the whole time. Yeah, 20 over 4 is 5. Excuse me. Now, let's match that to denominator 5 to see what happens. So remember, this is like 7.25 over 1. But if we want to match with denominator 4, we should multiply by 4 and also the denominator. And 7.25 times 4, let's do it here, is exactly 29. So it's 29 over 4. Let me copy this. Let me paste this and replace the 20 with 29. Okay, this is our pattern. And very quickly, before we find the general rules, because this video is turning way longer than I wanted, I would like you to focus on the on the pattern of the distance of m and n. Look, just the numerator, okay? The numerator follows a pattern of 5, 8, 13, 20, and 29, okay? And we said that this is not a linear pattern, but let's see what are the difference. So here we add 3, so 8 plus 5 is 13, so the difference is 5. And 13 plus 7 is 20, so the difference here is 7. And here the difference is 9 to get to 29. So again, it's not a linear pattern because the difference is not the same always. But what if we go further and we calculate the differences of the differences? So the difference between 3 and 5 is 2. The difference between 5 and 7 is 2. And the difference between 7 and 9 is 2. Okay? And here, the second difference, that's how we call it. When the second difference is constant, that means that the second difference is always the same, like in this pattern. That is called a quadratic pattern, okay? Like this. This is something that you will learn really soon, but now you can start recognizing what they are patterns where the second difference is always the same, and the first one not. So the numerator follows that kind of patterns, but look, what's the good thing about it is that you didn't need to know that, because you could find it from the context, because you know these are distances between points. Okay, so let's get to our matter. Finding the general rules for n, for m, and the distance, okay? So the general rule for m, okay? The general rule for m should look like a coordinate. Why? Because m is a point, so it's described by a coordinate. So let me resize again this. So it should look like parentheses and something comma something. Okay. Remember that m is the midpoint between a, which is always 0, 2, yeah, and b. But b is not fixed. B is changing, okay? How is b changing? Okay, what is fixed in b? The 0 is always fixed. You see, in b, there's always a 0. And you know that the x part of the coordinate is following a linear pattern because it's always increasing by 1. Okay, so remember, For linear patterns, um, you can say that the general rule, let's write it like uh, G. The general rule of the pattern should look something like this: the difference times the position plus or minus a complement. Um, this is also like the equation of a line, basically. What is the difference in this case? The difference is 1. Okay, the difference is 1 for this. And what is the complement? Remember, the complement can be found like position 0, which in this case, the position 0, stage 0, is 0. If we go back one position, it would be 0. Okay? So the general rule for this looks something like 1 multiplied by n plus 0. But remember, we like to simplify, and what is 1 times n? Just n. N plus 0. But again, we can simplify even further. What is n plus 0? Well, just n. So this n is the general rule for the x part of the coordinate of B. Look at it. And since we want to also find the general rule for M, which is a midpoint between this and this, we can just basically replace in the formula. Let's call this x1, y1, x2, y2, and let's replace. And then try to simplify as much as possible. So 0 plus n, x1 plus x2, divided by 2. And 2 plus 0, which is y1 plus y2. Okay, but that's not the simpler version of that general rule. We can simplify even further, because what is 0 plus n? It's just n. And what is 2 plus 0? Is just 2. So it becomes n over 2, comma, 2 over 2. But this can be simplified more. N over 2 can stay the same. You cannot do anything to this. But 2 over 2 is just 1. So this is the general rule for M. M is n over 2, comma 1 as a coordinate. This is the general rule for M. Sorry. So actually, let's write it here pretty in our answer. Nueva ecuación. So M equals to, parentheses. Actually, let me write big parentheses here. I want even bigger, but no problem. Fraction n over 2, wait, n over 2, comma, 1. That is our general rule. It looks like a coordinate because it's about a point. It's a point. It's a midpoint, actually. It comes from this. Okay? But now let's do it. Let's do the one for n. It's super similar. Okay? Remember, n is the midpoint between C. Okay? Let's actually go further. Between C, which is, I forgot what is C. C is fixed, is 0,6. And D. But D is changing. Remember. D is variating. So what is fixed of D? The 0. The 0, like in the previous case. But D is changing by 2. So something like this would be the difference for, like, the general rule for this part would be something like the difference is 2, so 2n plus the complement. The complement in this case would be 0 again, because if we go back to the position 0, it would be 0, 0. So yeah, but 2n times 2n plus 0 is just 2n. So that's D. And with that, we can find the general rule for n. Okay? By labeling x1, y1, x2, y2, and applying the formula of the midpoint. So x1 plus x2, 0 plus 2n. Y1, 6 plus y2, 0. We can simplify 0 plus 2n is just 2n divided by 2, and 6 plus 0 is just 6 over 2. Yep. But here, let me teach you a trick. When you have a term like this, and there's not an addition or a subtraction or something else, it's just a multiplication, you can cancel this, because it's like multiplying by 2, but also dividing by 2, so it's basically doing nothing, so only the n remains. And 6 divided by 2 is 3. And that's it. That is it. Okay. So n is this. Let me see if I got it right. Give me a second. Okay, yes, this is perfect. This is the general rule. But I just realized we made a mistake. Well, I made a mistake in the m. So let's correct it already. Let me write it really quickly here. N, comma, 3. Okay, but there's a problem here in our process for m. Let's correct it right away. I said that the coordinate for a is 0, 2. Yeah, but it's 0, 4. Okay, yes, it's 0, 4. This is a. I'm sorry. I'm so sorry. But since it's so late, let's correct it already. So it should be 4. So we should also replace this by 4. Yeah. And this becomes 4 over 2. And 4 over 2 is 2. And this is the correct general rule. I'm so sorry with you guys. You should have been screaming at me the whole time. This is the correct general rule. Because look, in m, the 2 is fixed. So it makes sense that here's the 2. The same. In n, the 3 is fixed. So it makes sense that here's a 3. Also, there's another way to do it. Just finding the general rule in this case directly. Okay. But now, finally, let's get to the elephant in the room. The general rule for distance, let me create here already a new equation. Distance from m to n. Okay. So we already have our general rules for m and n. Look. M is n halves, comma 2, and n is n, comma 3. So if this is our x1, y1, x2, y2, the distance between them is just replacing this information as a general rule in the formula. So x2 n minus x1 n halves squared plus y2 3 minus 2 squared. Let's simplify this. What is n minus the half of n? So it's the half of n. That should be squared. Plus 3 minus 2 is 1, and that should be squared. Okay, and let's do this really quickly. What is n halves squared? That is n halves times n halves, which is n times n is n squared. 2 times 2 is 4. So in the next step, we can replace. N squared over 4 equals, no, plus 1 squared, which is 1. Okay? Can we simplify this anymore? Nope. That's it. So let's write it like that. Well, actually, yes. We can do something to this. Because remember, this is a fraction, this is not a fraction, so we can write a 1 underneath this. And make the operation. So this is the same as saying that times 4 times 4, because we want to match the denominators, it would be n squared fourths plus 4 fourths, because that's 1. And that becomes, finally, if these have the same denominator, we leave it, and we just make the additions with the numerators. But n plus 4, n squared plus 4 is just n squared plus 4. We cannot do any more. That's the general rule. Well, the simplest version of the general rule. Remember, this one works, this one works. Actually, this one also works. But the simplest one is the last one that we got. Here, a fraction and a squared. So it would be n squared plus 4 over 4. That's our general rule for the distance. And look, it looks really similar to what we got in every single stage. A square root with a fraction with denominator 4 inside. So we can do test and verify really quickly. And the justification is basically for class. Okay? Well, actually, no. Let's do it. Let's do it. Even if this video is super long, already you can watch it step by step. So, test. We are going to check to test for position 1, 2, or 3. I select position 2. Okay? So, test for stage 2. So that means that n is 2. Okay, m. Let's take the general rule of m and replace n with 2. So it's 2, excuse me, 2 over 2, comma 2. But 2 over 2 is 1. 1, comma 2. It works. Don't forget to write it with words. It works. Or something similar. Now, n. Our general rule for n is n, comma 3. So, remember, we're testing for position 2. So it would be 2, comma 3. Well, yes, already it works. 2, comma 3. Wait. 2,3. Oh yeah, sorry, I just lost. We were looking for this one and it works. Yeah, sorry. I thought I made another mistake. One more in the video. Now, the distance. Remember, we're testing for position 2, stage 2. So we are going to replace n with 2. So it becomes 2 power 2 plus 4. The square root of that. And 2 power 2 to the power 2 is 4. So it's 4 plus 4 over 4. And that is 8 over 4. Let's see. Yeah, that's it. It works. Don't forget to write it in every single instance. Now, verify. Verify for position. For stage. So we could verify for stages 4 or 5. So let's do it with stage 5. Okay, so n should be 5. Let's do it one by one. M. So it's n over 2, comma 2. But n is 5, so it's 5 over 2, comma 2. But 5 over 2 is 2.5. So it's 2.5, comma 2. And in stage 5, m is 2.5, comma 2. So it works. Now, n. A general rule for n is n, comma 3. So it's 5, comma 3 since we are verifying for stage 5. It already works 5, comma 3. And for the distance, it's a little bit longer. This is n squared plus 4 over 4 and the square root of that. But remember, we're verifying for stage 5. So this becomes 5 to the power of 2 plus 4 over 4. And 5 to the power of 2 is 25 plus 4 over 4. And that is 29 over 4. So again, it works. Look. Okay, that's test and verify. Now, what about the justify? So justify is just basically using the context, which remember, we are talking about coordinates, midpoints, and distances, to explain where your general rules come from. So, for example, you could have said in an organized way this. Let me go back to the original things that we were doing. The justification is basically the process explained using the context. Don't forget about it. We have always a context for the pattern, so you should use the information from that. So we were said the coordinate A is this one, and the coordinate B is changing. Since the coordinate B, the x component of that, is changing in a linear way, which has this as a general rule, we can say that these are the coordinates of A and B. And using the midpoint formula, you can actually write that in your exam. Using the midpoint formula, we get to this, then we get to this, and finally we get to this. This is part of the justification. Well, actually, the justification for the general rule of M. Remember, you can use words to help the reader understand what you are doing and why, but don't write paragraphs. Something similar could be said to the general rule of N, which, remember, it's the midpoint between C and D. And C is fixed, which has these coordinates, but D the x component of that is changing in a linear way, and you can like actually, if you want, write the process for the general rule of this part, and say, since n is the midpoint between C and D, you just use the formula of the midpoint, replace, simplify, and get to this general rule. And that would be the justification for n. And something similar could be said for the general rule of D. Why do we get to this? Because the distance between m and n is a distance between 2 points. Therefore, we can use the formula of the distance between 2 points with the previous information that we had, replace, simplify, step by step, and get to this. Okay, and that would be the justification. In a really organized way, you should present it. Remember, you can aid yourself with words, but don't write paragraphs. And finally, what is more important in the justification, regardless of what kind of pattern you are having, you could have a linear pattern like we had here, or a quadratic pattern like we had in the numerator. But always refer to the context. Where do those numbers come from? Is this a context of coordinates? Is this a context of a polygon that is changing the measure of the sides? Is this a context of money spending? Whatever the context it is, you should talk about it in your justification. And that's basically it. Sorry for all my mistakes. Thankfully, I found about all of them. I expect to not make you so angry, and I hope this video is helpful for you. Well, see you later.